All right, so we're going to be doing inequalities. So we're going to focus first on number one. For number one, if you're looking at it, the first thing is we only have one inequality symbol. So what you're going to do is act like this is an equal sign, and we're still just trying to isolate our x. So if I had to isolate this x, I'm swinging over the inequality symbol. So I would first have to move the 10 by adding it for opposite operations. And then now I have 5 times x is greater than 25. So now I have to get rid of this 5. So to get rid of multiplication, I have to divide. I get x is greater than 5. So once your x is isolated, we're going to graph it on the number line here. So a few things to remember. If there's a line underneath the inequality symbol, this is when you do a closed circle. If there is not a line underneath the inequality symbol, that is an open circle. So if I'm looking at my inequality symbol here, there is no line underneath. So that means I'm going to use an open circle at 5. It doesn't matter where you put it if it's not numbered. I usually put it in the center. So it's an open circle, meaning that 5 is not included in my solution. And then this is x is greater than 5. So this means all my solutions are greater than 5. So greater than would be to the right, because these are the numbers, act like a number line. This would be like 6, 7, 8, 9, 10. So these are all the numbers greater than 5. For number 2, if you look at it, same thing. I'm trying to isolate my x. So I always distribute when I have parentheses. If you divide the 6 first, that's fine, but I'm going to distribute. So when I distribute, I get negative 6x minus 48. Okay, now that I distribute it, I'm going to move everything over to the right so I can isolate my x. So the first thing I'm going to move is this negative 48. So opposite operations means I have to add the 48. So when I add it, I get 64. And then once I get 64, now I have to divide by the negative 6 that's in front of my x. So I add it to 48, then divide by the negative 6. And then this is the other thing that you have to remember about inequalities. If you multiply or divide by a negative, flip your sign. So if you multiply or divide by a negative, you need to flip your sign. So see how I divided by a negative 6 here? So then that means I'm going to have to flip my sign. So if you multiply or divide a negative over to the other side, your sign flips. So it went from being less than to greater than. So when I'm looking at this, I'm going to graph it now. So looking at my inequality symbol, this is going to be an open circle. So I put an open circle. This doesn't divide evenly, so I left it as a fraction. That's why it's still just 64 over 6. And then this is x is greater than 64 over 6. So greater than is everything to my right. All right. So if you look at number 3 now, if you notice, there are now 2 inequality symbols. So there's one here in between the 0 and the x, and then there's also one here in between the 7 and the 11. So this is what we call an and statement, like the word and. So an and statement is when the x is sandwiched in the middle of 2 inequalities. So when you solve this, you're basically solving 2 inequalities at once. So I'm solving this inequality, x minus 7 is less than 11, and I'm also solving this inequality with the 0. So I'm solving both of them at the same time. So what you want to do is you want to isolate your x in the middle. So if I'm looking in the center here, I have a negative 7 that I have to get rid of. So to get rid of a negative 7, I have to add it. Whatever I do to the center, I have to do to my right and to my left. I'm like solving both of them at the same time. So 0 plus 7 is 7. These cancel. And then 11 plus 7 is 18. So you're going to get x in the middle, and then your outside numbers are the ones that are changing because you're going to be manipulating them with other numbers. Okay. And then how you graph this is these two numbers go with the inequality symbol next to them. So like the 18 is going to be closed because of this circle or because of this line underneath of it. And then the 7 is going to be open because of this inequality symbol. And you don't have to just make sure they're chronologically in order, meaning like 7's farther to the left than 18. And then for the and statements, and is when you shade in between. You're like sandwiched. Think of it like x is every value in between. X is in the middle. It's every value in the middle. So every value in between 17 and 18, or 7 and 18 would work. So look at number 4, and I'm going to give you a moment to try it. So you should have added 7 to all 3 sides first to get 22. And then the 7 goes away in the middle, and I'm left with 11x, and then 11 over here. And then divide everything by 11. So I get 2, because 22 divided by 11, and then these 11s cancel, and then 11 divided by 11. And then these two numbers are both open circles because of the inequality symbols. And then remember, if the x is sandwiched in the and statement, you shade in between. So I shade in between 1 and 2. All right, the next type has an or in the middle. So this actually says the word or, and you're solving them as 2 separate problems. Do not intermingle them at all. So like I'm going to focus on this first one. So if I had to solve this first one, I would add 4, and I would get x is less than or equal to -2. So I only touched this one. Then I'm going to jump over and solve this one. So this one I'd have to subtract 2. And I get x is greater than 3. Okay. So you solve them as 2 separate problems. Don't, like some people start adding 4 here and then they leak over and add 4 on this side. You solve this one and then you solve this one separately. All right, plot both numbers. So the -2 is a closed circle. So you have the line underneath. So -2 is closed. 3 is an open circle. And then for or statements, ors you shade on the outside. So everything that's greater than 3 or everything that's less than -2. Outsides. I think of or, outside, O, and O. All right, try number 6 here. So the or statements in the middle, solve them separately. So when you solve them separately, you should get, for this one, x is greater than or equal to 4 because you subtracted 3. And then this one is x is less than or equal to -4 because you divided by 6. So when I were to graph these, they're both closed circles, and then ors you shade on the outside. So closed circles, and then the or makes you go on the outside. And then lastly, we're going to go over how you write an inequality. So there's not much work to these ones, to be honest. So first thing with these, decide if it's an or statement or an and statement. So for this one, see how the shading's on the outside? So I know that this is going to be an or statement. And then this one, the shading's on the inside. So I know that this is an and statement, meaning my x is sandwiched in between them. Okay. So for the or statements, write them as 2 separate inequalities. So if I'm looking just at this shading, this is a closed circle. So I need the line underneath. And then my shading is to the left. So that means I want x is less than 1. Like these are all my values less than 1. Or it's a closed circle at 5 and the shading's to the right. So this is everything greater than 5. So this inequality is the x is less than 1, and then this one is the x is greater than the 5. And then make sure they're including 1 and 5. So equal to 1 and 5. This one's a little more tricky. I would start with the x in the middle. Put your numbers on the outsides. And then you read it from the x. So I need x to be greater than -1 and x to be less than 4. So your arrow should be pointing in the same direction, because I want to be greater than the -1 and I want to be less than 4. So I'm like sandwiched in between the -1 and the 4.